Today I'm going to share with you how I typically teach factoring trinomials to my students. So the first thing we typically do is each student has an individual whiteboard and we do a quick review of what some might call FOIL, or the double distributive property. So if I have 3x and I distribute it into the 2x, I end up getting 6x squared. And if I take the 3x and I distribute it into the 1 as well, I get plus 3x. I then take my negative 2 and I distribute it. So this negative 2 is going to go into both pieces of the second binomial. So I'm going to get a negative 4x, and I'm also going to take the negative 2 times the 1, and I get a minus 2. And we start to talk about where these numbers are coming from. So I say, where does the 6x squared come from? Well, it came from the 3x multiplied by the 2x. Okay, that came from the first. Okay, and then we say, well, where did the negative 2 come from? And negative 2 came from the last two numbers, right? Negative 2 and positive 1. The tricky part for students is this part right here, because this makes 6x squared minus x minus 2. And so asking where does this negative x come from, it doesn't come from the first or the last, like the last one. It comes from a combination of two things. It comes from both the outer and the inner swoops, okay? So we start to stress that that is a combination of two swoops, not just one. And I say in order to factor, we're going to do basically this process in reverse. Okay, so it's like reverse FOIL. So I call this many different things. It's been called many different things over the years. And some people call it the guess and check method. But I think sometimes that's kind of a negative connotation for students. They're like, am I just randomly guessing, or is there a process to this? Okay, and I, for many years, called it the reverse distributive property with GCF facts. Okay, but now I've started to call it a much simpler name, which is systematic factoring. There's a method to this madness, right? So I give them two main concepts to consider as we do this. And the first one is we always look for a GCF first, a greatest common factor. So looking at this trinomial, 3x squared plus 7x minus 6, there is no common factor to the 3, the 7, or the negative 6. Basically, there's not a number that I can pull outside a big parenthesis because there is nothing in common to all three of them. So if there's nothing in common to all three of them, there's not going to be anything in common to any of the binomial factors. And this is a huge, huge thing for students to realize. So if I'm breaking it into the two sets of parentheses, I can't have something like 3x minus 6 because the 3 and the 6 have a GCF. So if that happened, then I would do a second step where I would pull that GCF to the front. But looking over here, I didn't have a GCF that I could pull to the front. And I related this to something that my students know already, okay? So they know that when we create factor trees, like for instance, the factor tree of 100, if I start breaking 100 into its factors, like 25 and 4, or 20 and 5, and so on, if a number doesn't go into 100, for instance, 7 does not factor into 100 evenly, right? 7 is not a factor of 100. Therefore, 7 cannot be a factor of any of the smaller factors of 100. So if 7 didn't go into here, then it's not going to go into 25. And it's not going to go into 4 or 20 or 5 or any of those smaller factors. And that's what we're doing with this binomial factor here. 3 can't go into a binomial factor because it didn't go into the original. It wasn't able to factor to the front. So I really, really stress that. And when we stress this, we are able to eliminate a lot of factors. Okay, and then the second main concept is that once you put in numbers that satisfy the first and the last, all we're doing is a simple check of the outer and inner combinations. We're checking to see if those combine to be that middle term. So if I was going to do this process, I tell my students to think about the 3x squared, and they quickly say, oh, it has to be 3x and x. And then I say, well, what are the factors of 6? Well, I could have 1 and 6, or I could have 2 and 3. And then we think about what we're not able to put in parentheses. So right here, I can't have a 3 or a 6. And this has to do with concept number 1. Because if I put a 3 there, I now have a common factor of 3. And if I put a 6 there, I have a common factor of 3. But I didn't have that common factor in the original. So that leaves two possibilities. I can't have the 6, I can't have the 3. I can only have a 1 or a 2. So if I put the 2 here, that means I would need a 3 on the last term. And if I look at my outer and inner swoops then, I'm going to have a 2x and 9x. And I usually leave the signs off. Okay, and then we start saying, well, they need to be opposite signs in order to make the -6. And we need them to combine to be a 7. So in order to make a 7x, I need a +9 and a -2. So my signs have to be that way. And this takes a lot of the confusion out of factoring because students feel like there's a method. They're like, oh man, I'm able to eliminate all these possibilities. This makes it so much easier. So when we get into really challenging ones, and this is always the example that I give, it's much easier because we know things like I can't have a 4x and 6x because I have an even number here. So even if I did, 1 and 36 or 2 and 18 or 3 and 12, like if I put a 3 and 12 down, one of those has to have the 12. It has to have the even factor. So it's not going to work. I can't do the 4 and 6. It has to be an 8x and a 3x. Or a 24x and a 1, I guess. But as we do the 8x and 3x, and then we start going through here, and we're like looking at all these factors again, and there's a lot of them for 36. It can be overwhelming for students to see all those factors. But as we start putting things in, again, we can't have the 3 and 12 because then they would have the GCF with this 3. Same with the 6 and the 6. So we're left to like 1 and 36 and 4 and 9. And even with the placement of 4 and 9, I can't put the 9 here. That has to be the 4. And I can put the 9 there. I then have 32 and 27. And 32 and 27 can make -5 if I have -32 and +27. Okay, so there's a method to this madness. And then we start to eliminate possibilities by doing this systematic factoring. So after I give them one example and kind of stress those two things, I start to have them kind of play around with it. Okay, so they're using their hands, they're moving around, and they're working in groups of 2 to 3. And what I have are basically like 10 to 15 factoring problems, and they have little slips of paper that they're trying to match together. So I'm going to try to show you that on this machine. So if I have 2x squared minus 9x plus 10, I know that I'm not going to use the 3x and the 3x here. Instead, I probably want to start out with like a 2x. So I have two possibilities, 2x minus 5 and 2x plus 5. In order to make the +10 on the end, I would need basically an x plus 2, but my outer and inner aren't going to work for me in that case. I need to make a negative on the inner, okay? So students are seeing this without drawing things. I know I'm drawing to show you, but they're seeing, oh yeah, I'm going to need the -2, and I try to get them to kind of see that, oh yeah, now I need to check my outer and inner. When I do, I'm going to have a -4x and a -5x. And the goal is to get them to kind of feel this with their gut, to start kind of feeling that outer and inner as they're going, and to be able to see that that's making the -9x that they want. So on the next one, if I have 2x squared plus x minus 10, they're taking these little slips of paper and they're like, well, what if I try this one? Okay, in order to make the -10 on the end, since I have a +5, I'm going to need a -2. Okay, now they're quickly checking in their head without writing anything down, and they're saying, okay, outer terms make -4x, inner terms make 5x. Does this work? If I have -4x and I have 5x, am I combining to be +x? Yeah, that works. So that is correctly factored. From there, I do lots of things. I start to separate students out. I start to differentiate more. Some students will do some factoring puzzles that I call Tarsias. Other students will continue to work on these factoring games. I have 7 different factoring games. And then eventually we get back together as a class and students will do problems on a dry erase page where they're able to make mistakes, erase quickly. It's okay for them to realize that they don't get it right all the time the first time, okay? But they're starting to realize how all of these pieces fit together, and they're building their confidence by basing things on things that they already know.